Hello, I'm Robert, helping you if you're scared, voluntary fact checker. And this is a story that's scaring so many people today. And I don't think the media have the slightest idea how much it panics certain kinds of vulnerable people. There's nothing here to be scared of. They called this asteroid a planet killer. It was actually removed from the risk list 8 months ago. This means it can't hit this century. And then the term planet killer, it just seems to be something that an astronomer said in a conversation with the mass media. And this happens quite a lot. Mass media, they have interviews with scientists. The scientists say some colourful phrase in the middle of a long, complicated explanation, and they just say this colourful phrase, we call it a killer asteroid or something, and that becomes the headlines. And it's not the headline in the astronomer's mind. It's just a passing remark they said, which just like you might say, it's a bit like someone says to you in a media thing, and they say, when we start talking about meals, and they say, well, today I'm very hungry and I could eat a horse. And then next day you see this big headline saying, so-and-so said he could eat a horse. And it's a bit like that, this planet killer thing. And then they say, but he's far too small to eat a horse. But they might even say that, and they just say, and horses are, it just. So I won't elaborate that one any longer. But you get the idea. So the planet killer is extreme hyperbole. There's an ultimately low chance that an asteroid. First of all, an asteroid this big did hit Earth 700,000 years ago, and it obviously didn't kill the planet. Indeed, it didn't make humans extinct. These are our ancestors, and I've got to pick further down the page. I'll find them. There we go. So that's Homo erectus, and this is the debris from the strewn field from all these asteroids, and this is just thrown off from the asteroid impact, and it doesn't cover the entire Earth. These things don't get to the other side of the Earth. They travel a few thousands of kilometers. So if something like this hit the Earth and you were within a few thousand kilometers of the impact point, then you would need to protect yourself from tectites. It's just not a remote possibility. And then mixed up with that are these stone axes. And so this shows that they were in the areas that were hit by the tectites, which it's not nearly enough to do any harm, and they're really quite small things, about the size of your hand falling out of the sky. And amongst them, these stone axes, where these people were just immediately after the impact. So it's not a planet killer. It's just absurd hyperbole. And these people, they have no idea of the level of panic and anxiety that some people I help, including like people who they're at university and then they cancel their course at university because they're so panicked about asteroids, and people are afraid to leave their house because they have so much panic and fear, just based on stories, just based on the words, and not nervous people before then, not especially. So they're just leading a normal life, but got college, and then they've got to leave because they're so panicked. And these people just don't have a clue of the effect it has on particularly vulnerable people. So at this particular asteroid, then it was at a very steep angle to the Earth's orbit, and that's partly why it was missed. It's on an orbit where it should have been discovered long before, because it's on an orbit that crosses Earth's orbit, and yet it travels nearly out to Jupiter's orbit. That's Jupiter's orbit. This drops down to the line of Earth's orbit, and it should have been spotted out here. So why wasn't it? Two possibilities. One is that the Earth was always the other side of the Sun. That is really quite hard to arrange, but if it was opposite side there and also opposite side there, and it happened to be, and it was on the same side only when it was there and when it was there, kind of thing. And the other possibility is that that it's actually more of a comet, and it's getting a bit brighter between a comet and asteroid, as comets, very old comets, look quite a bit like asteroids as the ice gets evaporated away, and it was missed because it gets brighter as it gets closer to the sun, and it's only then that it's easy to spot. And so it's maybe not as big as it seems to be. And we've discovered nearly all the asteroids at this size, so it's not likely that we're going to find probably very few even in this particular family. And this particular family of ones that are very close to the sun, then they're not likely to go close to it. They're not very unlikely to find one. So there have been 857 found so far as of this video, and of those 857, then one remains in the risk list. 856, quite a few went into the risk list for a few weeks, sometimes for longer, sometimes for a year or more, and then were removed as they found the orbit better. And there's only one left. It's got a very remote chance in 2880. That's why it's still in the list, because of that chance in 2880. But it's expected to miss. This one would, if this one had a chance in 2880, it would still be kept in. So it's not like it. This one is the closest to the Earth at is 7 million kilometers to Earth's orbit, not to Earth, to Earth's orbit. And so Earth would very rarely be there at the same time it is. And that is so far away that it would take you, you'd need to travel non-stop for 326 days in a 747, 900 kilometers an hour. And you'd circle Earth 176 times, and that's the same distance as to where it is closest to Earth in its orbit. It's not close enough to be significantly perturbed by Earth over just a few centuries. So it's really, I mean, that's extremely unlikely. It's not, I think they're talking about maybe hundreds of thousands of years more likely, or millions of years, of the time scale before which it might actually significantly do something, have a risk of hitting Earth. Certainly tens of thousands, very unlikely in thousands of years. Just my rough guess based on the other things of this size. I'm not an expert, but just give you a rough idea. And so, known to be spotted long ago, and so I'm going through this very quick. We've got this, I've got a much longer video that goes into much more detail. We've got this space telescope that's being launched in 2025. We've also got the Vera Rubin telescope, which starts in 2023, that's next year, and that is going to cover, that's going to be able to look 4 times fainter objects, and because of that it'll be able to find out many more objects like this just in the first 2 weeks, if there are any out there to be found, of the ones that are further away from Earth. And then gradually over time it'll find lots of them, if there are any left. But they're probably only, a few years ago they said there's 2-3 dozen left. Now they don't say anymore. They just say that they found nearly all of them, and they don't give a figure for how many are left. So I don't know if it's maybe a dozen, maybe just a handful left. I don't know if I don't think they even know. But not many left to find at 1 kilometer size. And the risk is extremely low. And then this is what the effects would be, but I talk about that in a longer video. I don't think I need to go into any detail there. Just a rough idea, if it hit the at this size, extremely unlikely to hit an urban area, because only 1% of the Earth's surface. Slightly larger area, but a larger area like that, for something this big, so it's a somewhat bigger chance. But so I'm not saying this is likely, but if an asteroid this size was to hit New York, and it's not expected wait time is probably millions of years for that, then it would cause the glass windows would shatter all the way out to the Lake Erie and Lake Ontario. So you would have to evacuate, and then you'd have tektonics even further. So on the actual day of the impact, people would give people advice to go indoors and go in the basement if you've got one, and just basically just on the very remote chance that a tectite lands where you happen to be, which is very unlikely to happen. And as long as you're tracking it, and it's exceedingly unlikely you're not going to be able to track it, you'd likely see it years in advance. And just even with just the Atlas telescopes, they were talking about this size, that they'd expect to see them a year in advance. So you expect, and given some weeks in advance, when you get the radar to start looking at it, then you can get very precise observations, and then you can predict it exactly to 100 meters or so. And then you know exactly which region you have to evacuate. So even if you, at this size, even if you can't deflect it, nobody's going to die, although it's going to cause a lot of destruction. Nobody who follows the instructions is going to die, although it'll cause a lot of destruction at this size. And it's not going to cause extinctions unless it's hit some area where there's, if it's a tropical rainforest, where there's some species that only have a range of a few kilometers, a few square kilometers, then it might cause some species extinctions, not a mass extinction. Right. So, yeah, that's the risk list. It was removed from the risk list. Yes, I can't actually find. Yeah, this is an asteroid about 500 meters in advance. Yeah, this was 2020 AE1, which is 500 meters in diameter, and this one you expected wave climb millions of years of this size. I think 100,000, no, hundreds of thousands of years anyway. Tens, 500 meters, tens of thousands certainly, hundreds of thousands I think. But at this size, this one is a similar impact to a small hurricane at 500. 2019 asteroid was, a large hurricane at 500 meters, and it only went slightly above normal. So right. So sorry, I'm being confusing. I know I should have prepared this a bit better. With the CNN video, then one of the people on there said that what about the 2019 asteroid, which was discovered only after it flew past Earth, and it went slightly above the normal alert level, but it never. And so this is one that started off as being a low alert level, then it went above normal for the next flyby of Earth, and then it was removed suddenly from the risk list. So I just want to explain a little bit about why that happens. And then also just want to explain that this asteroid, it's very much smaller than 1 kilometer asteroid, and at this size, even so, it was quite surprising that the 2022 AE1 is, no, it's not 500 meters in diameter. What am I saying? It was only 70 meters in diameter. What am I saying? Sorry. The 2019 asteroid was only 70 meters in diameter, and at that size, because I was just stopping and thinking, there's no way we'd miss it at 500 meters. So at 70 meters in diameter, then it was, at this size, it is indeed like a small hurricane, a very small hurricane, like the Tunguska meteorite, which in 1908 killed 3 reindeer herders and a herd of reindeer, and flattened a very large area of forest. And that it is every few thousands of years, and in an urban area on average every few tens of thousands of years, because urban areas are only at 1% of Earth's surface. And so this asteroid, it's small enough so that in principle it could, but we'll spot most of these before they could hit Earth. And this one just went slightly above normal, slightly, it's my typo again, slightly above normal alert level, and it never reached anywhere close to needing public warning. It just went, sorry, not above normal, it just went to normal alert level. Sorry. This asteroid, it was at the no hazard level, and then it went from that to the normal level, which is 1, and then it was immediately removed from the risk list. So I've just mental note to fix that. I'll fix that after I do this video. Only went to normal alert level from zero hazard, and then never reached anywhere to no hazard, never reached anywhere close to needing public attention, which is level 4, and only some of the level 4s. That's another, that's 3 levels higher than this one went to. And then just want to explain how it happens that it goes up and then it gets vanished. So imagine that you've got, when you first discover it, you just see a point of light. The very first observation, you have no idea where it's going. Then the second observation, you have 2 points of light. Then you can start working out an orbit. When you have 3 levels of observations, that's when you can actually make a proper orbit. You've got loads and loads with just 2. So you've got 3 that are one after another. Then you've got a little fan of orbits, and then that's when you start getting a hazard thing. And then when you get when you start having a hazard corridor, as it were, then it starts up very wide. So suppose it starts off, say, 100,000 kilometers wide, and Earth in the middle. So then you say it's no hazard. It's very, very remote possibility. Now, as you contract it and you get better observations, you get it's 20,000 wide, and maybe Earth is just on the edge of that hazard corridor. And then you still say, well, the risk is increased because Earth is still in it, and it's a much smaller region. And then you get a little bit narrower, but Earth was just on the edge of the hazard corridor before, and now if you narrow it again, it might be that Earth goes out of it. And so it's only 10,000 kilometers wide, and Earth is outside that hazard corridor. Then it'll suddenly go off the list. So this is how it often happens, that if you watch the list, it might start no hazard, then go up to normal, and then just suddenly it's removed. And people just start saying, how did that happen? You know, it's getting more and more hazardous, and then suddenly it's removed. That's why. And this is absolutely normal. It happens over and over again. And yes, astronomers tell you about asteroids, but these are 2 examples. And they actually told you about 2022, whatever it is, what's the name of this asteroid again? 2022, February 2022, 2022, I forget its name now, AP7. And so they told you about it in February. And but it never hit the headlines in February, although that was the time when they didn't know, they hadn't yet removed it from the risk list. I was helping people back then, just before the Ukraine war, and nobody just before the Ukraine war was asking us about this. So I know for certainly it wasn't a big thing in the news, for sure. And now, 8 months after it was removed, it suddenly hits the headlines, and people getting all scared about it. And it's not. There's no logical reason to be scared of it at all, because it was removed way back then. So asteroids do tell us about it, but they didn't tell us about this. They didn't do a public warning, because it never reached the level where it's a public warning. It just reached normal. And the most likely next asteroid warning is if it ever does reach an asteroid warning in a century. And imagine that Tunguska one, it hit an asteroid in the ocean. So that's every few centuries, so probably not this century, but it might happen. Then you just get a big splash out of the ocean. And this would be really quite dramatic for astronomers if the splash would go up to hundreds of meters, but it wouldn't cause a tsunami. It's not big enough for that. And this splash just go back down to the surface. Most of it falls back into the hole that the asteroid makes. And so your personal risk is very minute. It's very small, far less risk than from lightning or even the very rare risk of death from a giant hailstone, which almost never happens. You get about 20 deaths from lightning in the United States every year. You get a death from a giant hailstone every few years. So it's a much, much lower risk of dying. But the risk from even the smallest asteroids, it's so low that there are no historical examples in the United States. So you can see how you have much lower risk of dying from a small asteroid. There's one example of a lady who had an extremely bad bruise on her thigh from a small asteroid a few decades ago, and that's it. And she had to go to hospital for it. So then that's the only example in the entire US history that is known. So your risk from these small asteroids, and it's just meteorites and bits of rock falling out of the sky from meteorites, and that risk is extremely low. And even, including the Tunguska one, the 3 very unfortunate reindeer herders and a few other examples every century, but your personal risk is much lower than your risk even from death from a giant hailstone. And this is my non-techie interface to the CNEOS Century Table, and this is what it shows on Tuesday, November the 1st. There's no hazard, and that's the highest risk. So this is just taking, if you go and look at the techie table, it's just, if you look at if you want to look at the techie table and convert it back to what I did with this, then look at the row that is labelled Torino. And if you go look down that column that's labelled Torino, and you should see loads and loads of notes. And sometimes you see a 1, and that is coloured green. The zeros are coloured zero, white or blue. Blue is just very small ones, and blue 50 metres, I think, no, 20 metres, I'm not sure, I can't forget now. And then the 0 ones are the white ones, the white ones are larger ones, but with no hazard. That's it rated as no hazard because the risk is so extremely small. And then above that sometimes you get a 1 like this one, which popped up in the beginning of the year, and that went up to normal. And the highest any has gone is yellow, level 4, meriting the attention of astronomers, and that was Apophis in 2003. And that's the highest that any asteroid has ever gone. And none of them have ever gone up to warning, the level of bread as a public warning. So all the public warnings have been fake that you may have seen in the news. And so anyway, I've got a long article about that here, so just go and have a look at that. And but just quick summary on that. And so if you go and look at the actual techie table, just look at the column called Torino. That's the only thing you need to look at on that table, and then look down it and see what the numbers are, and you sort it by the Torino column with the highest numbers on the top. And if the highest number is 0, then no hazard is the highest warning level. If the highest number is 1, and stormy or sorted with the Torino level, highest level at the top, then it means the highest level is normal. And then sometimes, maybe, only very, very rare, but I think in 2003 it went up to yellow. And so that's it. That's all you really need to know about that table. And if anything went up to even to meriting attention of astronomers in that table, and that's the lowest of the 4 yellow levels, then you of the yellow levels at 4, and if it's in the far future, that would be headline news. I mean, this is a normal 8 months later is hitting the headlines, so what the headlines would do if we actually really had a warning, goodness only knows. From saying the Earth's going to explode or something, or maybe they will be more maybe they'll be more accurate when you've got an actual proper warning, and let's hope so. Anyway, so that's that. And I think I've explained everything. But just I've got a longer video which goes into much more detail, and I elaborate on various things that I haven't talked about here. including things that I don't really talk about very much even in the article. So if you want to have a look at that, then that's why I'll put them both on this page. Go and read the page and you'll find much more, and you can look at the longest article and listen to a longer video if you prefer a longer video and to find out a bit more.